Hello, this is the last video in this course and just a quick wrap-up of what you have learned and what you can learn more about induction and where you can find the material. Let's start. Proofs by induction wrap-up. So you know that this induction principle can be compared to the domino effect. You have seen many examples of proofs by induction. And what kind of statements we can prove? Well, for example, formulas holding for all natural numbers or just from sum and zero to the end of the world. Then we can also prove some inequalities holding for all natural numbers or just from some point and zero. Other kind of statements like about divisibility, again holding for all natural numbers or just from some starting point. And now, interesting part is that this number n in the statement can be, for example, the size of a square matrix. And an example can be found in this linear algebra and geometry 1 course, where we show by induction that such an n by n determinant has this value, and this proof is conducted by induction with respect to the size of the matrix. Another thing, the number n can be a degree of a polynomial. And such an example is to be found in Precalculus 2, in the theorem about the divisibility. And actually you have gotten this proof of this theorem, which is conducted by induction, as a resource to this video. So you can read this one, but it's quite advanced. So just do it if you really have the right preparation for it. And you can find many problems to solve by induction all over the internet. One nice place is this LibreText, a book, a free of charge book, where you have this chapter about the principle of mathematical induction. There you can find some problems which you can solve in order to practice. And there is something called strong induction, and this is described in this Precalculus 1 course, and a theorem which can be proven by strong induction is the fundamental theorem of arithmetic about factorization in prime numbers of natural numbers. And here is the screenshot of this proof. You can go and watch this course if you want to. And now a question: is it always possible or a good idea to conduct proofs by induction? Well, sometimes not. So, for example, such a statement that none of the numbers of this type is integer, this cannot be proven by induction. And generally, negative statements would be very hard to prove. So, because there you will have to prove that if such a number for some n is not integer, that it must imply that the number with added 1 divided by n plus 1 is not integer, but it's I don't even believe that it's possible to prove. And another answer to this question is that sometimes proofs by induction are not optimal. For example, you can try to prove this inequality by induction. It is possible, but you will have to consider some cases, and well, this proof will not be really optimal for induction. But if you want to, you can prove this theorem even for for real number instead of just natural. Just by by observing that you can rewrite this inequality in this way, and then you will get an equivalent inequality which tells you that x minus 1 all squared is non-negative, which is obvious because it's a square of a real number. It is always non-negative. So in this case, choosing a proof by induction would be not such an optimal choice, but still possible. And we have some advantages of disadvantages of the method of proving by induction. The advantage is that it's kind of mechanical method. It contains always the same steps, sometimes more and sometimes less difficult, but it's always the same construction. And a disadvantage is that you must know the result in advance, or at least guess it, as we did it in case of sequences. And actually, I have prepared I haven't created it yet, but I have planned a course, Mathematics, Fun Tricks for Everybody, where I will show you the alternative to induction, fun ways of deriving formulas. And I will use, among others, some formulas from this course, which we proved by induction, but now you will see how they can be derived. So I hope that you enjoyed this course, I hope that you have learned a lot, and I hope that you will look forward to this new course, Mathematics, Fun Tricks for Everybody. It will also be a free course. Thank you for watching. Bye bye.